In this lesson, we're going to solve a couple of root equations. So here in example 1, I would like to solve for x in the equation the square root of 2x plus 1 is equal to 3. Our strategy is going to be to do something to both sides that cancels the square root. And that thing is going to be squaring both sides. So I'll take my equation, which is the square root of 2x plus 1 equals 3, and I'm going to square both sides. If you square the square root, they cancel, leaving you with 2x plus 1. And on the other side, if you square 3, you get 9. And the square root is gone, making this equation pretty easy to solve. You can subtract 1 from both sides, then divide both sides by 2, and you get your answer, which is x is equal to 4. It's worth checking to make sure that this is in fact true, so let's do that. I'm going to check that x equals 4 is in fact a solution. So I'll take the original equation, and in place of x, I'm going to put 4. And I'm asking, is this thing a true statement? Well, underneath the square root, we have 2 times 4, which is 8, plus 1 is the square root of 9, and the square root of 9 is 3. In fact, the square root always gives you a positive answer back, and it happens to work here, so we did it. There is one thing to look out for in this process, so I have this warning down here. Even though it did work for this problem, this process can potentially throw in what are called extraneous solutions, things that look like solutions at the end, but when you plug them back into the original equation, they don't work. So like here is an example really similar to this one. Before we even begin, I know this equation can have no solution. There's no way the square root of something is going to give you a negative number back, so immediately I know nothing works. But let's go through this process again to see what happens, where I take the left side and the right side, which is the square root of 2x plus 1 and negative 3, and I'm going to square both sides. That's my first step. Again, on the left, it's still 2x plus 1, but on the right, you have negative 3 squared. If you square a negative, it becomes positive, and if you square the 3, you get 9. Here's the issue. This step takes us to the same equation we just solved. There's a solution to this. You can subtract 1 from both sides. You can divide both sides by 2, and it still looks like x equals 4 is a solution. But there's no way that this is going to work. If you put this number into this equation, the answer is positive 3, not negative 3. So I know this one does not work. So there is no solution. So this is just something to look out for, where at the very end of this process, check your answer. If it works, great. If not, you throw it away, and there, in this case, is no solution to this equation. So let's try this one more time, but now looking at a different type of root. In fact, this equation has a cube root instead of a square root. In the previous question, there was no number next to the root symbol. If that's the case, we're talking about the square root. In fact, you could put a 2 in place of where this 3 is located in the previous example. And I put this fact up here. If you're looking to solve any type of nth root equation, a third, a fourth, a fifth root, the goal is to cancel this root by raising both sides to the power that appears here. So if you want to cancel a cube root, you're going to cube both sides. You're not going to square both sides. So let's go ahead and try to solve this thing and then check our answer at the very end. So first, I need to isolate the cube root by subtracting 1 from both sides. So this is the cube root of 3x minus 2 is equal to negative 2. I want to do this as my first step because I see I have a cube root, and cubing this side is going to cancel it, but I need this thing completely by itself. So the cube root is by itself. I'm going to cube both sides. And when I do, on the left I get 3x minus 2 is equal to, now if you cube negative 2, the answer itself is going to be negative, and 2 cubed is 8. Okay, so next I'm going to, add 2 to both sides, which gives us negative 6, and divide both sides by 3, which gives us an answer of negative 2. I want to plug this in just to make sure that it's in fact correct. So let's try that. We're going to check our answer. In the original equation, the cube root of 3 times negative 2 minus 2, then plus 1, is that equal to negative 1? Is this a true statement? Underneath the cube root, see, we have negative 6 minus 2 more is negative 8. Then we have plus 1. Is that equal to negative 1? Well, what's the cube root of 8? That is a number such that when you cube it, it's equal to negative 8. Therefore, I know the answer is going to be negative 2. And is negative 2 plus 1 equal to negative 1? And the answer is yes. This is in fact a true statement. So x equals negative 2 is a solution to the original equation. It turns out that if you have an odd root, that nothing's going to go wrong in this process here. You'll never get an extraneous solution for the equations that we're working with. But if you have a square root, the fact that the negative cancels is a problem. So if you have an odd power root, this process will always work for us. Whereas if you have an even root, like 2, a 4, or a 6, potentially you could get extraneous solutions.